Hi everybody, this is just a short video giving you some of the answers to worksheet 1 and worksheet 2, which we talked about during the lectures in week 1 of STAT100. For worksheet 1, question 3, there were 3 different case studies listed, and the first one was dealing with moisturizer softness. So there was a link there for a video, a YouTube video by Nivea, about 30 seconds long. Question A that I asked was, what does the advert try to suggest to potential buyers? And as with most advertisements, there's a bit of smoke and mirrors. They're trying to sell you a story. And in a nutshell, I would say for this, they're trying to tell you that buying Nivea will give you firmer feeling skin and have more confidence. Part B. What data is actually presented during the commercial? And if you catch some of the numbers that go past, you'll see that it says 73% of the 12,267 women surveyed believe that firmer feeling skin gives them the confidence to reveal a bit more. Now you will note, and I hope it's flagged in your head, that the product itself wasn't tested in a randomized experiment. So automatically, you should be thinking that there is actually no support for a cause and effect relationship here. Part C. Do you think the sample is representative? We're not given nearly enough information as to how women were selected for the survey or how the information was actually gathered. So at this stage, we can't actually assess whether the survey was representative or not. The second case study was an infographic looking at happiness in Australia, and you were given a whole bunch of smiley faces of different sizes with percentages next to them, which was trying to pass on messages about changes in relative happiness and also links between happiness and income. I asked you if there was any additional information that you would like to know to aid your understanding of this topic. And during lecture, when we discussed this, the class came up with lots of different thoughts, really useful ideas. And in a nutshell, one of the key things we really need to know is a lot more about how the data was actually gathered. We don't know how many people were part of the study. We don't know, if it was males, females, young, old, whole different sectors of the Australian population that were involved. And people were also curious about whether it was the same people that were asked in the first lot of surveys and the second lot of surveys. So whether the difference in happiness was between an individual or were between completely different samples. And we also don't know actually how the questions themselves were asked, so how an individual respondent, was scored in terms of how they gauged their own happiness. We don't have any information about baseline levels. And another thought that came up is that even if we did find or uncover some types of significant differences, we're not sure if that would actually translate into being a biological significance as well. Last thing I'm going to mention is obviously there could be a lot of different causes, different reasons for changes in happiness for an individual. The focus for the infographic that we looked at was income. So obviously some students put their hand up and said that income isn't necessarily the cause of happiness. I'm sure some would argue that it does help, but obviously there are a lot of variables. So we'd say there's a lot of additional confounding variables that would be important to include in this analysis when we look at any type of relationships that might exist. So let's move on to worksheet 2 now, and we'll skip straight to question 2 because we did discuss question 1 directly in class. So in this case, there was 3 different setups, 3 different scenarios, and for each of them I asked you to identify the response variable, the explanatory variable, and for each of those to say what type of data it was being collected. and also to come up with the observational unit. The first one, part I, asked what are the most commonly used internet browsers by students in each of the following UNE courses of study. So computing science, environmental science, and animal science. So in this case, the response variable is the actual choice of internet browser. So the type of data in this case is just categorical because it's a particular type. The explanatory variable, we think that potentially that the course of study that a student takes may have an impact on that response. So the course is the actual explanatory variable, and this again is a categorical variable. The observational unit in this case is the individual student. Part 2, I asked you about habitats in which butterflies prefer to feed. The response variable was a bit trickier in this circumstance because it's not actually contained in the question. You had to pull it out and think a little bit more. So you would think about the study itself and what you would actually be measuring. So you might come up with something along the lines of number of butterflies feeding in a plot over a 1 hour time period. So something, it doesn't have to be that, but I just wanted you to kind of open the door to make you think that in terms of an experiment, what would you actually be measuring? The example I gave here is quantitative. The explanatory variable is the different habitat type, so these would be categorical. And the observational unit is the plot where butterfly observations were actually taken. Part 3, in this case, we're looking at strength gains on different diets for tennis players. So the response variable is quite clear here. It's strength gains. Depending how you measure it, it could be quantitative or it could be ordinal, okay? So if it's quantitative, it could be number of kilograms gained in the bench press, for example. Ordinal could be perhaps you're at a particular level, 1, 2, 3, 4 on a strength scale for particular exercises or something like that. The explanatory variable here is diet. It's either the high protein or the low protein. And because it's a high and a low, it has an order to it, so we'd call it an ordinal variable. The observational unit in this case is the professional female tennis player that's part of your study. Okay, question 3 on worksheet 2. In this case, I asked you to redraw the bar graph. The one in the text gave you the percent of children with different myopia levels, and this was in relation to the lighting conditions that were in their bedrooms before age 2. So you're given the percent, and I asked you to redraw it with the raw counts instead. And so this is what it looks like with those raw counts. And what you can see here is that some of the patterns disappear. Okay, so suddenly, for example, if you look at the no myopia, the 2 first levels of none and some are suddenly at the same level. Okay, and this is in contrast to what you see in the first graphic when the percentage of children with no myopia that were in dark rooms is much, much higher than the other 2 categories. So that pattern, that trend disappears when we use the raw counts. And the reason for this is that there could be different numbers of children in the different categories. So if we're not looking at proportions, just because you've got a larger number of children in one particular group, the numbers could climb to being at the same as another category. However, the proportions are actually different. Okay, so that's a general rule of thumb that you can often see things a little bit clearer when you are allowing for percentages as opposed to raw counts. We'll talk about this a bit further along in the course when we look at contingency tables, and in those cases we always refer to conditional probabilities, which is what is happening when you're dealing with percentages as opposed to raw counts. All right, so hopefully this quick run through of the worksheet activities was helpful and recap some of the key ideas that we discussed during week 1. If you've got any questions, just drop me an email, stop by my office, or of course, feel free to post a question up on the STAT100 forums so we can discuss it further. All right, have a good week, keep studying, and I'll see you in class. Bye.